Master Python Pathlib, simplify file operations easily. Discover how to enhance your file handling skills using Python's Pathlib. By the end of this video, you'll perform complex file operations with ease. Welcome to our deep dive into Python Pathlib. Have you ever struggled with complex file operations in Python? Did you know that with Pathlib, you can simplify these operations and make your code cleaner and more efficient? Pathlib is a powerful addition to the Python standard library, offering an object-oriented way to handle file system paths. It's cross-platform, which means your code will run seamlessly on Windows, Mac, and Linux. Whether you're a beginner or a seasoned developer, mastering Pathlib will enhance your coding skills and streamline your projects.
Pathlib offers an alternative to the traditional os.path module, making path manipulations intuitive. Unlike os.path, Pathlib treats file system paths as objects, providing a cleaner syntax and more readable code. For instance, instead of using os.path.join, you can simply use the / operator to join paths. This object-oriented approach not only simplifies coding but also ensures that your code is less prone to errors and more maintainable. Pathlib automatically adapts to the underlying operating system, ensuring your scripts are cross-platform compatible. This makes Pathlib an indispensable tool for any Python developer. Creating and manipulating paths is straightforward with Pathlib. Begin by importing path from Pathlib and create a path object using a string that represents your file path. Pathlib allows you to navigate directories easily, using methods like parent, parts, and suffix. You can join paths using the / operator, which is more intuitive than os.path.join. Additionally, Pathlib handles both relative and absolute paths seamlessly, allowing you to switch between them with resolve. This flexibility is crucial for developing robust applications that interact with various file systems.
Pathlib simplifies file I/O operations with its intuitive methods. To read a file, use the read_text or read_bytes methods, which handle text and binary files, respectively. Writing files is equally straightforward with write_text and write_bytes. These methods automatically manage file modes for you, reducing the chance of errors. For instance, write_text opens the file in write mode, creating it if it doesn't exist. Pathlib enhances efficiency by providing direct methods for reading and writing, eliminating the need for traditional open calls and context managers.
Ensuring the correctness of file paths is crucial in any programming task. Pathlib offers the resolve method to convert relative paths to absolute ones, handling symbolic links and ensuring the path's existence. To check if a file or directory exists, use exists or is_file/ is_dir methods. These checks are essential for validating paths before performing file operations, preventing runtime errors. Pathlib's methods allow you to handle symbolic links smoothly, ensuring that your code interacts correctly with the underlying file system. This capability is particularly useful in complex directory structures or when dealing with external resources.
Handling errors gracefully is a key part of developing robust applications. Common file system errors like file not found error or permission error can be managed using try-except blocks. Pathlib aids in error management by providing clear exceptions and methods to validate paths before operations. For instance, checking if a file exists before attempting to read it can prevent file not found error. Additionally, Pathlib's methods ensure that errors are caught early, allowing for graceful degradation or alternative solutions. By anticipating potential issues and incorporating error handling, you can enhance the reliability and user experience of your applications. One of Pathlib's significant advantages is its cross-platform compatibility. It abstracts away the underlying operating system's path differences, allowing you to write code that runs seamlessly on Windows, Mac OS, and Linux. This eliminates the need for platform-specific checks and adjustments, simplifying the development process. Pathlib handles path separators and drive letters automatically, ensuring consistent behavior across different environments. By adhering to Pathlib's methods and avoiding hard-coded paths, you can develop applications that are robust and adaptable to various systems, enhancing their usability and reach.
Integrating Pathlib into real-world projects can significantly enhance maintainability and scalability. Its intuitive methods and cross-platform capabilities make it ideal for automation scripts, data processing pipelines, and web applications. For example, in a data processing script, Pathlib can manage input and output paths dynamically, adapting to different environments. In web applications, Pathlib ensures that file handling is robust and error-free, contributing to a smoother user experience. By leveraging Pathlib's features, you can build projects that are easier to maintain, understand, and extend, ultimately saving time and resources. Optimizing file operations with Pathlib can lead to significant performance gains, especially in large-scale projects. Start by using Pathlib's built-in methods for common tasks, reducing code complexity and avoiding unnecessary function calls. For instance, directly using iterdir for directory traversal is more efficient than manually listing files with os.listitor. Additionally, caching resolved paths and reusing path objects can save computational resources. By adhering to best practices, such as handling files in binary mode for large data and using Pathlib's context managers, you can streamline operations and enhance the overall performance of your applications.
As we wrap up, remember that Pathlib is a powerful tool that simplifies file operations and enhances your Python coding experience. Its intuitive, object-oriented approach to path handling not only improves code readability and maintainability but also ensures cross-platform compatibility. We encourage you to explore Pathlib further and integrate it into your projects for cleaner, more efficient code. Let us know in the comments how you plan to use Pathlib or if you have any questions. Don't forget to like, share, and subscribe for more insightful content. Vote on our next topic to stay engaged and informed.